Welcome back, friends. In this lecture, we will be discussing about an example of S attributed SDT. Okay. So here this example belongs to a simple disk calculator. It's a simple disk calculator. Okay. So these are the production rules and these are the relevant semantic rules for this production rule. So the first production rule is L tends to En. So here N is nothing but it is representing the new line. Okay. So the equivalent semantic rule for this production is print of E dot val. So kindly understand that for all the non-terminals, val will be represented. And for the terminals, we will be representing the some numeric values for this example. So it is mentioned in the term called digit. So this digit will contain its value in the simple table. So when we are fetching the value of the digit, it can be retrieved from the symbol table. Okay. So the digit is represented with the term called lexval. Non-terminal is represented with the term called val. Terminals are represented with the term called digit and lexval. Okay. So the first production rule, as I mentioned, it represents the print E dot val. And the second production rule, it represents E tends to E1 plus T. So the meaning is E dot val equal to E1 dot val plus T dot val. So here we are discussing about the synthesized attribute. So always the synthesized attribute will um, evaluate its attribute value with the help of the child nodes. Okay. So for this E dot val, the child nodes are E1 dot val plus T dot val. So the next production rule is E tends to T, that is represented as the semantic rule is represented as E dot val equal to T dot val. Then T tends to E1 T1 star F. So the relevant semantic rule for this is T dot val equal to T1 dot val star F dot val. Then next production rule is T tends to F. The relevant semantic rule is T dot val equal to F dot val. Similar to F tends to parenthesis E, open parenthesis E, close parenthesis E. The represented semantic rule is F dot val equal to E dot val. Here the parenthesis is used simply for grouping the values. Okay. The last production rule is F tends to digit. So F dot val equal to digit dot lex val. So here digit is a terminal. So the value of this terminal will be stored in the symbol table. While we are retrieving the value, we can fetch the value from the symbol table. So now we will see a simple example. So for example, I will be representing this expression 1 plus 2 star 3n. So normally, so how we can evaluate is, so according to the board mass principle, so 2 and 3 will be evaluated, then 1 will be added with this. So normally, so the value will be that is equal to, so 3 to 6 plus 2 plus 1, 7n. So, okay, n is nothing but it represents the new line. So after printing this n, so the cursor will be, the compiler will move to the next line. So in order to mention that we are representing with n. Okay. So now we have to construct an annotated parse tree. Okay. Annotated parse tree for this example. So annotated parse tree is nothing but which contains the a tree which contains the values of the attribute, which contains the or which derives the values of the attributes. So annotated parse tree means a parse tree which contains the values of the attributes or derives the or it derives the values of the attribute. So now we will construct an annotated parse tree for this example. 1 plus 2 star 3n. So the first production rule is L tends to E, then N. Okay. Then for this expression, you can see here first the arithmetic operation comes here. So we will be evaluating the arithmetic operations in the parse tree now. So we have to check in which production rule arithmetic operation is coming. So we have left in the left hand side we have E, and on the right hand side we have N. So L is the start symbol. So we are starting from the L. So we have to check from E. Okay. So you can see here uh, E tends to E1 plus T. So E tends to E1 plus T. So we have to mention with E. Okay. So E, then derive this E with, so you see here, E tends to E1 plus T. Okay. Then this E can be further derived as T, because we have to come for the digit. Okay, we have to retrieve the terminal. Then T tends to F, then F tends to digit. So same way here T. So when you are fetching this T, so next what we have to mention? So this T should contain um, a multiplication operation. So again, T can be derived with T tends to T T star F. T tends to T star F. Okay. So you can see here T tends to T star F. This T is again further mentioned as F, and F is further derived as digit, and this F is further derived as digit. Okay. So now this is the annotated parse tree. So now we will include the value. So you can see here digit has been included a digit dot lex val. So digit dot lex val. So what is the first value? So first value is 1. Okay. So the first value is 1. So digit dot lex value, that is equal to 1. So you can see here if it is F tends to digit dot lex value. So you see here the semantic rule for the production F tends to digit. So F dot val equal to digit dot lex value. So F dot val equal to digit dot lex value. So what is the value of the digit dot lex value? That is 1. Okay. So now come to the T. So what is the production rule? So what is the production rule? T, that is T tends to F. For T tends to F, the semantic rule is T dot val equal to F dot val. So T dot val equal to F dot val. What is the value of F dot val? That is 1. So now again you go to E. So E tends to T. Okay. E tends to T. If the production rule is E tends to T, what will be the semantic rule? E dot val equal to T dot val. So E dot val equal to T dot val, that is 1. Okay. So now we have to go to this E. So before substituting this E, we have to derive these parse trees. It's okay. These attributes. So again, digit dot lex value, that is digit dot lex value is the second value. You take the second value, that is 2. Okay. Now the same thing, F tends to digit dot, F tends to digit means the semantic rule is digit dot lex value. So digit dot lex value equal to 2, F dot value equal to 2. So when you're going for T, again T dot val equal to F dot val, that is the value is 2. Now in order to mention, in order to derive this t, we have to derive this first. Digit dot lex value, that is equal to the third element, that is 3. Okay. So f dot val equal to that is digit dot lex value, that is equal to 3. Okay. Then t dot val equal to, you see here, this t tends to t star f. This production rule, t tends to t star f. So what is the semantic rule? T dot val equal to t1 star t1 dot val star f dot val. So t1 dot val is 2, star f dot val is 3. So 2 into 3, that is equal to 6. Okay. Now E tends to E1 plus T. Okay. E tends to E1 plus T. That is the semantic rule is E1 plus E1 dot val plus T dot val. That is 1 plus 6. So E dot val equal to 7. So now you derive this. So what is the E tends to? So E tends to you. So this E dot val equal to 7. So E dot val equal to 7, and this will be merged with this. So the finally the value will be 7 here. Okay. So this is the a simple example for synthesized synthesis attributed SDT. So S attributed SDT. So in the next class or in the next lecture, we will be discussing about the example of the L attributed SDT. So I hope you have understood the concept well. Thank you.